bet you didn't know when that was going to happen, did you? Well, that's fine in a controlled lab setting such as this, but it's not so good in real life. The type of composite that's being tested in there is called carbon fiber reinforced plastic. It's incredibly strong, incredibly light, and it has applications in numerous areas, from the paneling of F1 race cars to the structure of the new Boeing 787, and many, many more applications. However, it's not like metal, which is conventionally used in such applications. It can't be welded together, which is inconvenient, and instead must be bolted or bonded together. Now, bonding them means that a strong glue, such as a marine epoxy, is used to combine two strips of carbon fiber plating. Now, the difficulty with bonded joints is that it's impossible to view the bonded area. This means that it's really difficult to see any damage in the area, which severely limits the applications of bonded joints. And usually, it takes a lot of external sensors and heavy equipment to monitor exactly what's going on in there. Something I don't think maintenance crews would be too happy about. But what if there was a way to monitor the damage that's much simpler and much more time efficient? Well, my nervous system is a type of sensor, right? It'll be able to tell how much stress is in that area, how much pain I'm in, where the pressure is coming from, everything. What if that sort of sensing was compatible with something like this? Fortunately, there is a way we can do that. These are carbon nanotubes. They're a form of carbon that's strong, light, and most importantly, highly conductive. This epoxy is essentially non-conductive, meaning that an electric current can't flow through it. This epoxy is highly conductive because we have integrated carbon nanotubes into its structure. And there's an interesting phenomenon at play here. As this becomes more damaged, that is to say, more cracks form, it becomes less and less conductive. How is this useful? Well, think about it. This sample, when it starts out, has resistance that is none. As more damage is done to it, more and more cracks form, increasing its resistance. Therefore, knowing those two, if the resistance increases, we know there's damage. The best part about this is my research has validated it. Even still, there are no sensors attached, meaning that all the equipment we need to do this are contained within the epoxy, and the only external device needed is this multimeter, which is much, much cheaper compared to the equipment back at the lab. Keeping things simple is incredibly useful. Maybe one day, composites will be so safe and reliable that everyone can use them. Probably not today.